Hello everyone. Today we're going to start something new, propositional logic. And propositional logic, otherwise known as formal logic, is when you let letters represent sentences. It's more algebraic, more precise. So instead of saying it's raining, we would just represent that with the letter R. If it's raining and snowing, R.S or R and S. If it's raining, then it's hot, R horseshoe S. And if it's not raining and it's snowing, it would be not R.S, so negation sign R. Then you'll see there are these signs and or, if and only if, then, which are connectors between sentences. So we're going to start exercise 6.1 number 1, and you're assigned a few. I'm not going to do the ones you're assigned, but the hope is that after I do these, you'll be able to go back and do the ones that are assigned. I'm going to start with number 6 there. This is on page 337. Chanel has a rosewood fragrance if Lanvin does. So Lanvin, if Lanvin does, then Chanel does. It's saying if the one, then the other. If this, then that. Okay, so you would start almost reading the sentence backwards that way. And in the pages that you were assigned to read, namely those pages, not all for this coming week, but you'll see the logic of the language there. Then we're looking at number 8. Number 8 says, Reese Witherspoon wins Best Actress only if Martin Scorsese wins Best Director. Only if doesn't reverse the order of the sentence. So, Reese Witherspoon wins Best Actress only if Martin Scorsese wins Best Director. R implies M. R for Reese, M for Martin Scorsese, okay? Armani will launch a leather collection given that Gucci rejects skinny models. Well, given that is like if. Given that it's going to be hot today, Jones will perspire. So given that Gucci rejects skinny models, Armani will launch a leather collection. Okay, so G implies A. Okay. Number 11 says Bill Gates does not support malaria research unless Warren Buffett does. So unless is like or. It's this symbol here. You'll read about that in the pages prior. So Bill Gates does not, we're saying not Bill Gates, B, unless Warren Buffett does, or W. Okay? So one or the other will come true. 12, Mercedes will introduce a hybrid only if Lexus and BMW do. So Mercedes, I'm up to 12 here, will introduce a hybrid only if Lexus and BMW do. So if the first piece, then the second two combined. Read it again. Mercedes will introduce a hybrid only if Lexus and BMW do. Okay, so we've got 2 to go. Either Mariah Carey sings pop and Elton John sings rock, or Diane Krall sings jazz. So either Mariah Carey sings pop and Elton John sings rock, so it's M and E, Mariah Carey and Elton John, or Diana Krall sings jazz. So M and E or D. Okay? The 2 together or the other. Finally, number 15, not both Jaguar and Porsche make motorcycles. Here I'm going to ask you to think of it in a certain way. If Jaguar and Porsche both made motorcycles, that would be J and P. But when we apply the not, we're putting a not outside parentheses saying, and then the negation sign goes through, called the tilde, the German word, but the symbol of negation goes through the whole sentence. So it's false that Jaguar and Porsche make motorcycles. This is like saying one or the other doesn't. Okay, so that's 6.1 Roman numeral 1. There you're just translating sentences into symbolic notation, so we can use them later in other ways. Then in 6.2 rather, Roman numeral 1, you're being asked to, there's more practice with those kinds that we just did if you like it. In 6.2 Roman numeral 1, we're into truth functions: negation, conjunction, disjunction, and conditional. So the pages I'm going to be using for this are just 4, 341 through 344, actually on to 345, biconditionals. And then you should be able to do the exercises starting with 6.2 Roman numeral 1. You'll see that under 6.2 Roman numeral 1 it says, identify the main operator in the following propositions. Well, I'll save you some reading time and tell you that the main operator is that operator that governs the largest part of the formula. Okay, so we have here 6.2(1), and I'm going to do together with you 5, 7, 8, and 9, and then you can go back and do the ones that you're assigned, okay? Number 5, as you can see, says M and B is true, or the negation of, and then the brackets, whatever in the brackets. Well, what's the main operator there? The one that governs, as I said, the largest part of the formula. Clearly the OR does that, because the OR brings the first disjunct together, or the wedge is a symbol of disjunction. Okay, so we're just going to write that in. All right, the wedge. You can write it in English too, it's just the wedge. But you don't have to do it that way. And so that governs the largest part. So I want to go back to number 7. The horseshoe in 7, 6.2 number 1, governs the whole formula, because it's the first piece. The negation sign only applies to the beginning and end of the brackets, notice. And then the horseshoe brings together the first if and then the following then, which is C or N. You can call it the horseshoe and draw it like that, which is the symbol of implication, or just write the horseshoe. I think they're asking you to write out the word here, but that's okay. I'm using both for you. And then we're going to get to number 8. Well, 8 has, you'll notice, brackets and then negation and disjunction inside, and then they close brackets. But what brings that entire formula together right up to the letter H? It's the triple bar. The symbol of if and only if. So you just call it triple bar. Okay, that's the main operator. Again, that's what we're looking for. One more, and that's number 9. Again, we have here E and all the rest that's in the brackets. Well, what brings all of that together? You might be tempted to say the triple bar, but you'd be wrong there. It's the dot that brings together the first part of the conjunction, E, and then the entire second part, which is, I'm not even going to read through that, but the whole second part. So those are your answers there. Using those answers, you can go back and do the ones that you're assigned, okay? Then we're going to try something different here, 6.2, Roman numeral 2. Okay, now we're doing something different here. It says in 6.2, Roman numeral 2, write the following compound statements in symbolic form. That's the first thing. Then use your knowledge of the historical events referred to by the simple statements to determine the truth value of the compound statements. So 2 things, symbolic form, and then say whether it's true or not. You'll see how it's done rather easily. Number 5 says Edison invented the telephone, or Custer was killed by the Indians. Okay, so Edison invented the telephone would be represented by E for Edison. Or Custer was killed by the Indians. We're just going to use the wedge and then C for Custer. Well, Edison did not invent the telephone. Alexander Graham Bell did. So that would be false for the Edison part. Or was Custer killed by the Indians? Yes, he was. Now, according to the operators here, the truth functions, if there's one true in a disjunction, is it true? Yes, the whole thing is true. Only one needs to be true. So because of the you used your knowledge of the historical events there and the knowledge of truth functions to show that false or true equals true. Let me illustrate it another way. If I say it's going to be sunny or snowy today, and one of those things turns out to be true, my entire sentence is true. Only one of the disjuncts need be true. Not both. It's a disjunction after all. It means or. And by the way, or in logic, it's called the inclusive or. Not either or as you would expect in the dictionary. It means one or the other is true and maybe both. One or the other and maybe both. Let's go on to number 6. Number 6 says Julius Caesar conquered America if Napoleon ruled France. Okay? Julius Caesar conquered America if Napoleon ruled France. Well, I see if, an if-then statement. We're going to start with the if part. If Napoleon ruled France, then Julius Caesar conquered America. Okay? Well, Napoleon did rule France. That part is true. Did Julius Caesar conquer America? No, that part is false. With a truth function if-then, when is a truth function false? Only once. when the antecedent part, that is to say the part before the horseshoe, is true, and the consequent part, namely the part after the horseshoe, is false. That combination yields false. Think of it in another way. Think of it as making a promise, a horseshoe. If it's raining, then the streets will be wet. When is my statement or my promise false? When it is raining and the streets are not wet. Highly unlikely, by the way, but if there was a T horseshoe F, that would be false. So this is false, because the antecedent was true and the consequent was false. Finally, number 8, and I hope this will allow you to go back and do the others, it says Lincoln wrote the Gettysburg Address if and only if France bombed Pearl Harbor. If and only if, some of you will recognize having done the reading, and that means triple bar. So Lincoln wrote the Gettysburg Address, we're going to put, this is for 8, if and only if France bombed Pearl Harbor. Well, in an if and only if, the truth values have to be identical. The truth values are T and F for now. We're going to introduce unknown in a moment. But Lincoln wrote the Gettysburg Address is true. If and only if France bombed Pearl Harbor, that's false. They didn't. The Japanese did. So is true equivalent to, that's what triple bar means, it's equivalent to, is it true equivalent to false? No, never. So that expression is false. When would the triple bar be true? When you had false on either side. False is equivalent to false, or true is equivalent to true. You might think of this in terms of Aristotle's law of identity. Everything is equal to itself. But a true is not equal to a false, and vice versa, of course. Okay, so we've done 6.2 Roman numeral 2. I trust that you'll be able to go back and do the assigned exercises now that I've done those few with you together. Now we're going to introduce something a little different here. We're going to try to let these, we're going to solve some problems 6.23, and let me read the instructions for this section. I think you'll get these rather quickly, I hope you will. Determine the truth values of the following symbolized statements. And it says, whenever you see A, B, or C, you're going to let that equal true, and X, Y, and Z, you're going to let that equal false. Okay? A, B, and C true, X, Y, Z false. I'm not going to write that up there, although sometimes in my own instructions, my notes to myself, I do, just to remind myself. And then you're going to do number 5 to start. Number 5 says, if B, then not Z. Okay? Well, B we said was true. We're going to drop down to true. Implies not Z. Do it line by line so you don't confuse yourself. True comes down again. True implies not false. What's not false? True. Well, if we're dealing with a horseshoe, true implies true. It's only false, we said, when it was true implies false. So that must be true. And there's a sense of accomplishment when you start to get these right, and you get a kind of confidence too. 6 says Y implies not A. I know sometimes I do my horseshoes like a horseshoe, and other times like a sideways wedge, but Y implies not A. Okay, so Y, false in the antecedent. I know this is going to be true already. Okay, but false implies not true. False implies, because not and then A was true. And false implies false. False implies false is true. You might be quizzical right about now. If you read the part about the horseshoe and the laws, the rules governing that that relationship, again, if I say the Yankees win tonight, if the Yankees play today, they're going to win. Well, if it's false that they played and false that they won, all bets are off, right? So instead of saying unknown or some other value, we just fill in true. My statement, if the Yankees play, they're going to win, is only false, notice, in one circumstance. That A, they played, and B, they lost. No other combination, so we just put true instead of unknown or anything like that just yet. Okay, next we're going to do number 8. All right, we're going to take 2 more of these, what I call substitution problems, where you substitute true or false for the letters. And then we're going to have one more exercise after this where we substitute some unknowns as well. So we're up to 8. And again, you're going to use these, what I've done here. You can play and pause and see what I say, and then go back and do your own there. So here we're told 8, 8 is B triple bar Y. Well, we were told that B is true, so whenever I see a B, I'm going to substitute the truth value. If and only if, or equivalent to, Y is false. Is true ever equivalent to false? No. The only time that yields a true, the triple bar, is when you have equal values on both sides. Okay. And number 9 is not C implies Z. This looks like it could be longer. Not B, C implies Z. Maybe not. Well, we were told A, B, and C were true. So not C is not true, implies Z, which is false. We've seen this one before. We had a false implies false down there, okay, below. So false implies false is true, we said. By elimination, it's only false when true implies false, so that is true. So now we've done 4 from that section. We have one more section to go. I hope you've been following along, but the good of the video is that you can stop and start it as you choose. Now I'm going to do 6.23. Hello everyone again. This is the last exercise. There'll be 5 problems with it. And here we're introducing just one more variable. As before, we're going to let A and B be true. The instructions say, 6.24. Y and Z are false, and P and Q are unknown. So we're going to substitute U for unknown when we see those. Okay, so let's proceed. Number 3 says Q dot Y. And okay, so whenever I see Q, I was told to substitute unknown. And whenever I see Y, I'm supposed to substitute false. Well, that's interesting. We don't know the value of unknown, and I'm going to say what the 2 values are. It could be true, right? Could be false. Do we know which? No. Does it matter? No. We have a conjunction, the dot. What's the truth function for dot? Both must be true. If you say it's going to be sunny and above 90 today, both parts of your sentence have to be true for the entire sentence to be true. If one part is false, the whole sentence is false. So, unknown dot false. One false alone tells us the whole statement is false. Okay, so let's try number 5. Number 5 says P implies B. Okay, and we're told here again P, we're going to let that equal unknown, implies true. You should see this already. If you have true in the consequent of a conditional statement, that is to say a statement that makes use of a horseshoe, it's automatically true. No matter what this is, and it can only be true or false, right? Doesn't matter. If it's true implies true, that's true. False implies true, still true. It's true. Okay, number 6. Just 3 to go, hang in there. Okay, so 6 is Z implies Q. Okay, whenever we see Z, we're going to let that equal false. Implies Q, that's unknown. Well, again, we're dealing with a conditional, and when you have a false in the antecedent, it's automatically true no matter what this is. If this was false implies false, it would be true. False implies true, it would be true. So, go to school on your truth values for the conditional. So this is automatically true. Number 8, the most interesting one, says P is equivalent to not P. Well, here's where Aristotle's law of contradiction may serve you well. Can anything be equal to its negation? No, not ever. So, no matter what P is, even though P is unknown, let's put it down there. P is unknown. Is unknown equal to not unknown? Can anything be equal to its negation? See, whatever P would equal, whatever U would equal here, would be true or false, or true are the only 2 possibilities, right? That something's unknown. Well, if it was a false, then that would equal not false is true. If it was true, that would equal not true, it's false. So nothing can be equal to its own negation. You cannot be here and not here at the same time. So this has to be false. And again, one of Aristotle's famous 3 laws of thought, the law of non-contradiction. Number 9, last one, a little more this time. P implies A, implies Z. Okay? First do what's in the parentheses there. So P, we're told, is unknown. Keep the parentheses there. Unknown implies true, implies false. Okay? We know what unknown is? No. Unknown, but unknown implies true is automatically going to be true, because anything horseshoe true, as you see with the truth functions, is automatically true. Unknown can only be true or false. Both make that true. But that gives you true implies false. If you have a true antecedent and a false consequent, then the conditional statement is false. If it's raining and the streets are wet, is only false when it's raining and the streets are not wet. So then you have false. So those are the 9. Armed with that knowledge, you can go back and do the exercises that you were instructed to do, I hope, and we'll go over them. We'll go over more of this when I see you again on Thursday evening. So have a good week.